To wrap up this chapter, let's look at the assumptions that were behind the linear regression model that we came up with. So it's going to be talking about the error. So let's talk about what the error is. Supposing this is my regression line and it was used to fit these data points. So these are the data points, and we found out that this line was the best fit line going through those data points. The error term will be the difference between your actual line that you fitted, this heavy line here, and any of the actual points. So it's the difference between the actual and the predicted. So the predicted is the black line, or the estimated is the black line, and the actual, those black dots. So all these points are showing errors. Now, if I have all the population data, these red lines are called errors. If I only have sample data, then these red lines are called residual lines. So when we're talking about samples and populations, we always have different notation and slightly different terminology, and it applies here. So as far as the error or the residuals are concerned, we know that the error is a random variable with mean of 0. That's what we're going to assume. Well, that's what we were assuming. The variance of the error terms is the same for all values of the independent variable. So it's like saying the variance, the spread at any point around this line is about the same. The spread of the data, see, the spread is about the same at all points. Okay, approximately the same. It doesn't have to be exactly the same, more or less the same. This feature where the variance is about the same is called homoscedasticity. The next item here is that the values of epsilon are independent of each other, meaning the residuals or the error terms are distributed randomly and not influenced by the residuals in previous observations. If the residuals are, if they're not independent of each other, then they're considered to be autocorrelated, which may be covered in another course. But here we're assuming that the residuals or the error terms are independent of each other and not influenced by any previous values or observations. And the final thing here is that the error epsilon is normally distributed random variable. So if you remember the features of a normal distribution, it looks like this, and basically you've got most of the observations here in the middle, and as we move away you get fewer and fewer. If I try to draw it on top of here, it would look something like this. So basically most of your error terms would be very close to the center right here, and as we move away we get fewer and fewer of these error terms occurring. One other feature that I just want to tell you about was the idea of cause and effect. Just because you have shown statistically that there is a linear relationship between two variables, it doesn't mean you have cause and effect. So sometimes there is cause and effect. If, for example, I find there's a relationship between the amount of hours that you spend studying and your exam score, the more hours you study, the higher your exam score. Your hours, the additional hours you spend studying are causing your exam score to improve. If I look at the price of a car against mileage and find there is a linear relationship there, and I find that as the mileage increases, the price of the car decreases, well, again, there will be cause and effect there, because as you put more miles on your car, it will cause the price to fall. But there are other times you could find a relationship which is called spurious, which is a misleading or not a real relationship. It's only real in statistical terms. So, for example, there is a famous actor that lives in Newport Beach, and they found a relationship between the number of movies that he makes and the number of people that drown in swimming pools each year. So there's not cause and effect there. Him making more movies is not causing people to drown in swimming pools. It just happens to be what is known as a spurious relationship or correlation they're not causally related. They're related mathematically or statistically, but they're not causally. There's not cause and effect there.